Welcome back to our session. So for today we are going to study about two most important and foundational algorithms in machine learning. So what's that? Linear regression and logistic regression. If you truly understand these two algorithms, you have built a strong foundation in machine algorithm. So stay till the end because I'm going to explain everything in a simple. Let's begin. So before we have to start our session, the last video I gave some question time to you. So for this is the answer for that. So you just refer to you. Okay, we'll start our session. Linear regression. So linear regression is a supervised machine learning algorithm. That means it learns from labeled data. So its main purpose is to predict continuous numerical values. So continuous values in the sense it's like marks, salary, house price, temperature, so like that. So for simple example it will be defined like that. Imagine you want to predict a student's exam score based on the number of hours they studied. So you observe something simple. So more study has higher exam score. So that's a linear relationship, no? So the input that is considered as a has studied. So it's called a independent variable. Okay. The output that is a exam score. So this is called the dependent variable. So we use the independent variable to predict the dependent variable. So for here we have to clearly explain what is an input and then what is an output. So input is an we have to give a independent variable and then output is an dependent of the input variable. Is that clear? Okay. So the next one in linear regression. Okay. So in linear regression we draw a straight line through data points, but not just any line. We draw the best fit line. Okay, so it's not like a simple line. So for the best fit only it will be going like a straight line. Okay, so the best fit line is the line that minimizes the error between actual values and predicted values. So when we get a best fit line in the sense, so when we get a minimum of error in a actual value and a predicted value means then only we have to get a fit line, that means best fit line. Okay, so for that purpose we have to use a linear regression algorithm in a machine learning. Okay, so what is an error? So in that error is simply described as a actual value minus predicted value. Okay, so wanted to reduce that error we use a method called sum of squared errors. Okay, so error in the sense, so actual value is there, no? So in that value minus predicted value, so what value we have to predicted it. So in both we have minus it in the sense we have to get a error value. So in that error is called the sum of squared errors. Okay, so next we have to explain in the equation of the best fit line. Okay, so the mathematical equation of simple linear regression is y equal to mx plus b. So where here y is predicted value in the sense it is a dependent value. Okay, so x is the input means independent variable. Okay, so y is the output value which we get it, and then x is the input value which we give it to the we have to see in the types of linear regression. So for here in the type of linear regression has a two types, simple linear regression and then multiple linear regression. Okay, so for first one, simple linear regression. Okay, so simple linear regression is quietly defined to it's a one independent variable. Okay, so it's a simple words if we have to explain in a simple linear regression in the sense it is a one independent variable. Okay, so for it is a multiple linear regression in the sense it has more than one independent variable. Okay, so for example of the simple linear regression in the sense, so salary based on years of experience. Okay, so for in that salary that is based on the years of experience in our company or else an organization, in a school, college, whatever it is. Okay, so for based on the experience only they have to give it the salary. Okay, so this is the example of the simple linear regression. Okay, multiple linear regression, we already defined that one. So more than one values or more than one independent variables are there means that is called a multiple linear regression. So for multiple linear regression example is as house price based on area, location and a number of rooms, like that only, no. So it will be changed, and then it's not in a one independent value, it has a more than one independent value because of it depends on the area, it depends on the location, it depends on the room. So that's why it will be changed. Okay, so this curve is like a S shape. Okay, so a S shape curve is there, no. So if probability is greater than or equal to 0.5, it belongs to class 1. Okay, it less than 0.5, it belongs to class 0. Okay, so it will be moving to the up in the sense it will be going to the class 1, it will be moving to the down in the sense it will be going to the class 0. So then we have the types of logistic regression. So for here three types of logistics regressions are there. Okay, the first one is binomial, the second one is multinomial, the third one is ordinal logistic regression. Okay, so binomial, what is a binomial? So it has a two possible categories. Okay, so two possible categories in the sense we already discussed, no, yes or no, pass or fail, 0 or 1. So for like that is there means in that kind of type is called the binomial logistic regression. Okay, then multinomial regression. So multinomial regression in the sense this is used when the dependent variable has three or more possible categories, so that are not ordered. For example, classifying animals animals into categories like a cat, dog or sheep. So for like that, so it handle the multiple classes. So multiple classes in the sense that is called a multinomial logistic regression. Then ordinal logistic regression in the sense this type applies when the dependent variable has three or more categories with a natural order or ranking. Okay, so here also it will be categorized as the more values, but what is the difference between multinomial and then ordinal? We'll see in the sense. So multinomial it doesn't follow the order, but ordinal it's follow the order and then ranking. Okay, so for example, so including rating like a low, medium, high. So for that like that order it will be followed it. Okay, so for binomial, multinomial and then ordinal, it's is the under the type of the logistic regression. Okay, so the next one is assumptions of logistic regression. Okay, so independent observations, binary dependent variable, then linear relationship with log odds, no extreme outliers, and then large sample size. So these are the assumptions of the logistic regression. So it has a independent observation. Okay, so independent observation is there means it will be considered like a logistic regression. And then binary dependent values, that means we have to take a two values, 0 or 1, yes or no. So for like that two categories are there means that is considered like a logistic regression. And then linearity relationship between independent variable and log odds, and then no extreme outliers. So the data set should not contain extreme outliers as they can distort the estimation of the logistic regression coefficients. Then large sample size, so it requires a sufficiently large sample size to produce reliable and stable results. Okay, one is understanding sigmoid function, we already discussed this one. So S curved shape is there, and then it will be moving to the 0.5 in the sense above the 0.5 means it will be considered like a class 1. It will be below 0 means below 0.5 in the sense it will be considered like a class 0. Okay, likelihood function for logistic regression. We have to see in the likelihood function for logistic regression. So for this goal is to find weights and bias. So for here we have to consider weights as a W and bias one is equal to B. So in that maximize the likelihood of observing the data. So for each data point I it will be represent like a for y equal to 1 in the sense. Okay, so for here we have to take a binomial logistic regression. So 1 in the sense what are the predicted probabilities we have to get it, and then 0 in the sense what are the predicted probabilities we have to get. So for like that only it will be derived to here. Okay, so y equal to 1 in the sense in that will be predicted probabilities will be p of x comma b comma w equal to p of x. If in case for y equal to 0 in the sense the predicted probabilities will be 1 minus p of x comma b comma w equal to 1 minus p of x. So for that values we have to apply to here, and then we have to get in a value. So for here we have to use the natural logs on both sides. So we have to use the logarithmic algorithms to both the sides. So here we have to use the instead of p of xi equal to 1 minus p of xi. So here we have to simplify that one, and then this is known as the log likelihood function. Okay, next one is we have to coming to the end of the session, question time. So before the question time I'll just recall the topics we have to which are we have to complete it. Okay, so first of all linear regression. So it predicts the continuous values. The straight line equation is there, means that is the best fit line. Okay, and then it's minimize squared error. So it will be getting a maximum, it will be getting maximum error reduced way. Okay, so for how it will be reduced that error in the sense, so we already know the formula, actual value minus predicted value. So for these we have to minus it and then get the error value. Okay, so the next one is logistic regression. So it predicts the probabilities that in the sense yes or no, 0 or 1, true or false, like that. And then it uses the sigmoid function, so that means S curved function, and then it's used for the classification. Okay, so both are is the supervised learning algorithms, and both are the parametric models, and both are foundational in machine learning. So for we have to discuss this session in a linear regression and logistic regression. So for you have to answer this one question. The next class I'll give the answer to that one. Okay, so thank you.